We would like to welcome you to our channel, dedicated to exploring the fascinating world of STEM. Join us as we uncover incredible scientific discoveries and innovations that have helped shape the world we live in. Delve into the incredible stories of the brilliant minds behind these achievements and be inspired to cultivate a love of learning and a passion for STEM. Our aim is to broaden your horizons and deepen your understanding of the world, all while showcasing the wonders of science, technology, engineering, and mathematics. So come along with us and let's explore the marvels of STEM together. The concept of a sun-centered or heliocentric universe was a revolutionary idea in astronomy that challenged traditional beliefs and paved the way for modern scientific thinking. This thesis provides a comprehensive analysis of the historical and scientific aspects of the sun-centered universe, tracing its origins from ancient Greek astronomy to its acceptance as a scientific fact in the 17th century. Theory. The sun-centered universe, also known as the heliocentric model, is a scientific theory that places the Sun at the center of the Solar System, with the planets orbiting around it. This theory replaced the earlier geocentric model, which placed the Earth at the center of the universe and the Sun, Moon, and planets orbiting around it. The concept of the heliocentric model can be traced back to ancient Greek astronomy, with figures such as Aristarchus of Samos proposing that the Sun, rather than the Earth, was at the center of the universe. However, it was not until the 16th century that the Polish astronomer Nicolaus Copernicus published his seminal work, On the Revolutions of the Celestial Spheres, which proposed a fully developed heliocentric model. Copernicus's theory was met with controversy and opposition, particularly from the Catholic Church, which saw it as a challenge to traditional beliefs. However, his work laid the foundation for further observations and discoveries, including those of Galileo Galilei, who observed the moons of Jupiter and provided evidence in support of the heliocentric model. The contributions of Johannes Kepler, who formulated the laws of planetary motion, and Isaac Newton, who developed the laws of motion and gravitation, further solidified the heliocentric model as a scientific fact. Today, the heliocentric model is widely accepted and forms the basis of modern astronomy and our understanding of the universe. The impact of the heliocentric model on modern astronomy cannot be overstated. It opened the door to a new era of scientific thinking and observation, paving the way for the development of modern telescopes, space probes, and other astronomical tools. It also challenged traditional beliefs and encouraged critical thinking and skepticism, which remain central to the scientific method today. The ancient Greek astronomers. The ancient Greek astronomers made significant contributions to the development of astronomy, including the development of early theories of the universe that eventually led to the heliocentric model. One of the earliest known proponents of the heliocentric model was Aristarchus of Samos, who lived in the 3rd century BCE. Aristarchus argued that the Sun, rather than the Earth, was at the center of the universe, and that the Earth and other planets orbited around it. While his theory was not widely accepted at the time, it paved the way for future developments in astronomy. Aristotle, who lived in the 4th century BCE, believed in the geocentric model, which placed the Earth at the center of the universe. He argued that the Earth was composed of 4 elements: earth, air, fire, and water, and that these elements determined the motions of the planets and stars. While his theories were influential in their time, they were eventually challenged by later astronomers who provided evidence for the heliocentric model. Ptolemy, who lived in the 2nd century CE, is perhaps best known for his work, the Almagest, which presented a geocentric model of the universe. Ptolemy's model, which included epicycles to explain the motions of the planets, was widely accepted for many centuries and was the dominant theory of the universe until the Renaissance. Despite the dominance of the geocentric model, the work of Aristarchus and other early proponents of the heliocentric model continued to influence later astronomers. For example, the work of Copernicus in the 16th century was greatly influenced by the work of Aristarchus, as well as the writings of the Islamic astronomer al-Biruni. The Copernican Revolution. Nicolaus Copernicus was a Polish astronomer who is best known for proposing the heliocentric model of the universe in the 16th century. His work, On the Revolutions of the Celestial Spheres, laid out a comprehensive model of the Solar System in which the Sun was at the center and the planets orbited around it. Copernicus was born in Torun, Poland in 1473 and began his studies in mathematics and astronomy at the University of Kraków. He later studied canon law at the University of Bologna and worked as a cleric for much of his life. It was during his spare time, however, that he pursued his interest in astronomy and began developing his theories about the structure of the universe. One of Copernicus's main observations was that the apparent motion of the planets could be explained more simply if they orbited around the Sun, rather than the Earth. He also observed that the retrograde motion of the planets, which appeared to move backwards at certain times, could be explained by their relative positions in the solar system. Using his observations, Copernicus developed mathematical calculations to support his heliocentric model. He also proposed that the Earth rotated on its axis, which explained the daily motion of the stars. However, his theory was met with controversy, particularly from the Catholic Church, which believed that the Earth was at the center of the universe based on the teachings of Aristotle and Ptolemy. Despite the controversy, Copernicus continued to refine his theory and published his work, On the Revolutions of the Celestial Spheres, in 1543, just before his death. His work laid the foundation for future astronomers, including Galileo Galilei and Johannes Kepler, who provided further evidence for the heliocentric model and eventually helped to establish it as a scientific fact. The Galilean moons. Galileo Galilei was an Italian astronomer who is best known for his observations of the heavens using a telescope. In 1610, he made a groundbreaking discovery when he observed 4 moons orbiting around Jupiter. This discovery provided further evidence in support of the heliocentric model of the universe, as it demonstrated that not all celestial bodies orbited around the Earth. Galileo's observations of the moons of Jupiter were significant because they contradicted the geocentric model of the universe, which held that all celestial bodies orbited around the Earth. Instead, they supported the heliocentric model proposed by Copernicus, which held that the planets orbited around the Sun. However, Galileo's discoveries were met with opposition from the Catholic Church, which saw them as a threat to their authority. The Church had long held the belief that the Earth was at the center of the universe and that all celestial bodies orbited around it. Galileo's discoveries challenged this belief and put him at odds with the Church. In 1616, the Catholic Church declared heliocentrism to be heretical and prohibited the teaching of Copernican theory. Galileo was eventually brought before the Inquisition and forced to recant his beliefs. He spent the remainder of his life under house arrest, and his work was not widely accepted until long after his death. Despite the opposition he faced, Galileo's discoveries had a significant impact on the development of astronomy. His observations provided further evidence in support of the heliocentric model of the universe, and his work helped to pave the way for future discoveries in astronomy. Kepler's laws of planetary motion. Johannes Kepler was a German astronomer who is best known for his work on the laws of planetary motion. He was a key figure in the development of the heliocentric model of the universe, as his laws provided a mathematical basis for the model proposed by Copernicus. Kepler was born in 1571 and studied at the University of Tübingen, where he initially trained to become a theologian. However, he soon became interested in mathematics and astronomy and began to pursue these subjects more seriously. One of Kepler's main contributions to astronomy was his work on the laws of planetary motion. In 1609, he published his first law, which states that the planets move in elliptical orbits around the Sun, rather than in perfect circles as previously believed. He also observed that the speed of a planet varies throughout its orbit, with it moving faster when it is closer to the Sun and slower when it is farther away. Kepler's second law, which he published in 1619, states that a line joining a planet and the Sun sweeps out equal areas in equal periods of time. This means that a planet moves faster when it is closer to the Sun, and slower when it is farther away. Finally, Kepler's third law, published in 1619, states that the square of a planet's orbital period is proportional to the cube of its average distance from the Sun. This law allowed astronomers to calculate the distances between planets and the Sun with greater accuracy. Kepler's laws of planetary motion had a significant impact on astronomy, as they provided a mathematical basis for the heliocentric model of the universe. They allowed astronomers to accurately predict the movements of planets and provided a framework for further discoveries in the field. Newtonian physics and the sun-centered universe. The impact of Newtonian physics on the heliocentric model of the universe was significant. Newton's laws of motion and gravitation provided a scientific explanation for the behavior of the planets in the Solar System, and helped to solidify the heliocentric model as the accepted model of the universe. Newton's three laws of motion are as follows. These laws allowed scientists to explain the motions of the planets in terms of the forces acting upon them. In particular, the second law allowed scientists to calculate the gravitational force between two objects, which was crucial to understanding the behavior of the planets in the Solar System. Newton's law of gravitation states that every object in the universe attracts every other object with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. This law provided a scientific explanation for the behavior of the planets in the Solar System, as it showed that they were all subject to the same gravitational force from the Sun. In addition to explaining the behavior of the planets in the Solar System, Newton's laws of motion and gravitation had a significant impact on the development of science as a whole. They provided a framework for understanding the physical world and helped to establish physics as a legitimate scientific discipline. In summary, the sun-centered universe, also known as the heliocentric model, was a revolutionary idea that challenged the widely accepted geocentric model of the universe. The heliocentric model proposed that the Sun, not the Earth, was the center of the universe, and that the planets orbited the Sun in elliptical paths. The heliocentric model had a significant impact on the development of astronomy and science as a whole. It challenged traditional views of the universe and forced scientists to question long-held beliefs about the nature of the cosmos. The contributions of key figures such as Aristotle, Ptolemy, Aristarchus, Copernicus, Galileo, Kepler, and Newton were crucial in the development and acceptance of the heliocentric model. Scientific evidence in support of the heliocentric model includes observations of the phases of Venus, the moons of Jupiter, and the retrograde motion of Mars. These observations provided strong evidence for the heliocentric model and helped to dispel doubts about its validity. The heliocentric model is still relevant in modern astronomy, as it provides a framework for understanding the motions of the planets in the Solar System. The discovery of exoplanets, or planets outside of our Solar System, has further confirmed the validity of the heliocentric model, as the same laws of planetary motion apply to these planets as well. In conclusion, the sun-centered universe, with its historical significance and contributions of key figures in astronomy, has shaped our understanding of the cosmos and provided a framework for modern astronomy. The scientific evidence in support of the heliocentric model has been crucial in its acceptance, and its ongoing relevance in modern astronomy continues to impact our understanding of the universe. Thank you for joining us on this journey of discovery and exploration. We hope you've enjoyed learning about the wonders of science and the incredible breakthroughs that are shaping our world. From uncovering the mysteries of the universe to tackling some of the most pressing challenges facing humanity, science truly has the power to transform our lives and our world. We invite you to continue exploring the amazing world of science, and to join us in our mission to promote scientific understanding and knowledge. Stay curious, keep learning, and always keep asking questions. Who knows what incredible discoveries lie ahead? Thank you for being a part of our community, and we look forward to continuing this journey together.